In this episode, we're going to talk about the journey to Silverstone, where our Formula student team is hoping to race the university's first electric racing car. Hi, I'm Christian Matthews. I'm a subject head here in the Faculty of Engineering and Technology, and I'm the faculty advisor for the Formula student team here, our e-racing team. We're recording today in the engineering workshops in the Formula student lab, and I'm really pleased to have with me Cameron Reedy and Rhian Griffith, who are two current and former members of the Formula student team, and we're going to talk about the journey to Silverstone. So, Cameron, do you want to just introduce yourself quickly?
Yeah. So I'm Cameron Reedy. I'm the head of the LJMU e-racing team. I'm a master's. Well, I've just finished my master's at John Moores.
And Rhian?
Hi, I'm Rhian Griffith, and I am the ex-team manager of the Formula student team. We were just LJMU racing then. We didn't have an electric motor, and I'm now a mechanical engineer at a small robot company.
Great. So let's start off by just talking a bit generally about what Formula student is. Okay, so and what's going to be happening in Silverstone in July. So Rhian, do you want to tell us from your perspective sort of what the Formula student competition was about when you were doing it?
Yeah, so initially when I came to the university, Formula student was an extracurricular activity. It was something that I could get involved with, apply what I learned in my degree and get hands-on and sort of make me stand out when I left university. But quite quickly it became a little bit more than that. It becomes sort of like your passion, and you get really excited and involved with designing, building and testing this race car that hopefully, if all goes well, throughout the year you can take to Silverstone and possibly other competitions around the world.
Okay, awesome. So Cameron, tell us more about the sort of size and shape of cars that we're going to see at Silverstone.
Yeah. So the cars at Silverstone are kind of designed to a very specific set of rules. I can't remember off the top of my head. I think about 1 meter wide and a couple meters long, probably less than that in length. And yeah, they're very small and compact, kind of Formula style open wheel cars. Some with aero devices, some without. And yeah, there's a mix of powertrains as well. The conventional internal combustion engine, EV, and I think there's maybe a couple of hydrogens and hybrid ones, I'm not too sure. And yeah.
Okay, so going back to your time as team leader for the Formula student team, Rhian, what sort of engine did you install in the car?
So 2015 was when I was the team leader, and we had the Honda CBR 600 engine, so an internal combustion engine taken from a motorbike that we would modify, design the chassis around and then install into the single-seat race car. I think when I was at Silverstone, the majority of teams were still using internal combustion engines. There was a handful of electrified cars, but I don't think there were any sort of hybrids, or I know there's even autonomous.
Yeah, there's an
cars
autonomous series now, yeah.
So with the internal combustion engine, then, what were the kind of the main challenges to using that type of propulsion system?
So reliability was a big thing that we would sort of suffer with. What we would do was take an engine, a used engine with hours already on it, and then we would get it back here and sort of rebuild it. We're not engine rebuilders. That's the first challenge that we would have to face. You know, we'd have to learn how to strip an engine and sort of refurbish it, replace all the seals, that sort of thing. And then also we would need to design the auxiliary systems around it. So we would have to design an air intake system and an exhaust system that is completely different from the motorbike that the engines come out of. So designing all these bespoke systems around a combustion engine was really tricky, and we would often suffer with sort of like, yes, we'd have good power but not good reliability, or that sort of a problem.
Sure, so those sort of engines are real complicated, right? Loads of moving parts.
Yeah. So I can't tell you the number off the top of my head, but you know, hundreds of moving parts, and I know that's sort of different to the electric motor, where you might get a lot less moving parts, but we would have to deal with high temperatures, sort of lots of vibration, and like seals failing and that sort of thing, and so we would really have to make sure that the engine was as reliable as it could be and tested, but not too tested, ready for the competition, so that it did get over the line.
So we're gonna move on in a bit and talk about why LJMU's chosen to build an electric car and the motivation behind that. But just to contrast what Rhian's just shared with us about the combustion car, tell us a bit more about the electric propulsion system.
Yeah, so it's much less kind of hands-on in our perspective, because it's basically you have quite a large battery, a motor controller and a motor, instead of what would have been, I guess, an engine and an ECU. So whereas the engine is just like one thing, the battery and the motor kind of are the engine, but there's two parts. So the motor controller is kind of the brain between the motor and the powertrain system. The motor and the battery, which is an accumulator. What did you want me to say on that?
Well, that's fine. So what sort, what type of motor it is that you're using?
It's a Yasa 750, which puts out a peak torque of, I believe, 750 Newton meters, which is insane. Potentially a bit overkill, but yeah. Okay,
so they're the same types of motors that go in the sort of wheel hub of supercars these days, right?
Yeah. I think it was used in a. It's not. Is it Bugatti?
The Bugatti.
No, Bugatti. Yeah,
not
I think
familiar with
no.
Bugatti. I know that McLaren have got something similar to that in the front hubs of some of their cars. So
it's a type that's kind of used in a range of supercars. Right.
So this isn't a washing machine motor salvaged from the table.
Definitely not. No.
And so you talked about the battery and the motor being almost like one thing. So in some ways, though, for our listeners, they might think of the battery as being a bit more like the fuel tank on a car. So Rhian, how big was the fuel tank on the car? How much fuel could it hold?
So what's really handy is there is a limit on how much fuel you can hold, but we had, I think, a 5-litre fuel tank on the top of my head, and we would have to sort of manufacture a tank that fitted that in, and we'd make it out of aluminium, and we'd have to get it welded here on site, and there's always a lot of hassle with whether it's going to be leaking and are we going to have enough fuel at the end of the competition, because if you've got too little fuel then you lose points and that sort of thing. So I guess it's in some ways more complicated than a battery, but there's no sort of logic that you have to have with it. So then programming everything you need to do with the battery and the motor, I imagine, is much more difficult than just welding an aluminium tank together.
Okay, so I think we can sort of visualise sort of the volume of 5 litres. So how many litres do you reckon your battery would be, Cameron, in terms of the volume of it?
I reckon probably at least 20 litres, probably more than that. It's pretty big and it's pretty heavy as well. I think about 60 kilograms. 400 volts. Not too sure on the amp output, but yeah, it is very.
So 60 kilos. So I guess 5 litres of fuel is gonna weigh like what, 4 kilos, maybe 4.5 kilos plus the aluminium. There's quite a big difference there. Okay.
It was always kind of an afterthought for us as well. Like we would always think, where are we going to fit the fuel tank? And that's not really something you can afford to do with a battery.
Yeah, like when you were saying how you fitted the chassis around the engine, it's kind of, obviously the motor's pretty small, probably like, I don't know, 30 centimeters wide by like 50 centimeters like long.
Yeah.
So it's really small and like compact, but the battery is like obviously huge, kind of like the size of an engine. So I think we fitted the rear end around the motor, but the battery is definitely something you kind of have to integrate before you or whilst you're designing your chassis. But
So that's interesting. So from your perspective, it kind of requires a whole different design ethos.
Definitely.
Okay. So let's just talk a little bit before we move on. Let's talk a little bit more about the event itself. So when you get to Silverstone, Rhian, from your perspective, what's the event about? What different things are you expected to do there? What's the order of priority, right? And what happens next?
So the event is made up of static and dynamic competitions, or events, sorry, and we compete in all of them. When you arrive, it's a bit of a mad panic sometimes, depending on how prepared you've been, but you've got to set up your pits. It's part of your competition. You've got to have a really smart looking pit where you do all your presentations from, and all the judges, they come around and they look at that and they look at your car. So that's the first thing that you want to get slick, and you want to make sure that you've got all your spares ready for any failures that you have out on the track. And then it's not actually wheel-to-wheel racing, so there's an acceleration event, a sprint event, and an endurance event, and I'm just trying to think of what the figure of 8 is called.
The skid pad.
Yeah. So they're all events that are designed to test your car in a slightly different way. The endurance event is the big one. It's when you've got to do, I think, at least 20 laps. I can't remember the distance now. Maybe you do, Callum.
I think it's about a kilometre and up.
Yeah, so about 20 kilometres, and that's what you're really trying to make sure your car is ready for and your driver's ready for it, and that's the biggest amount of points that you can get for the competition. So you've got to sort of prepare for a load of little different things, but that's the biggie.
Okay, so 20 kilometres, right, it's not very far, sounds easy, is it?
No, it's not. It's not easy. I'm not a driver, so I can't tell you physically whether it's easy or not, but you know, we had I think before 2015, the last time we completed those 20 kilometres without a failure was 2012, I think so, and that was in Spain.
Yeah.
So, you know, we'd gone a long time to actually completing this event, and when you think, well, 20 kilometres, you've got all year to prepare for that, but so much goes wrong along the way. So yeah, it was really satisfying to actually complete that without any hiccups in 2015.
Yeah, so I remember being there at 2015 and the sense of relief when the car sort of finished that endurance event, because it took us from a position where we'd had a couple of what I'll call lucky years in the early days where we completed endurance events almost sort of effortlessly, it seemed, and then suddenly we had this run of bad luck, and then suddenly it kind of became increasingly difficult to imagine what it would take to complete. So, you know, there's that resilient thing there, isn't there? Kind of, as you say, preparing all year and then having the kind of the pain and kind of tragedy of it. Well, first world problems, right? the tragedy of a non-completion in the event. So from your perspective, Cameron, in terms of preparing for the event, sort of how many different balls have you trying to juggle at the moment? How many plates have you got spinning?
Yeah, it's a tough one because you've got to prioritise actually getting to the event with the car. You've also got to kind of considering your documentation stuff, so your design report, your costing, and yeah, you kind of want to get to competition, so have a car, but you don't want to kind of just be a bit of a wet wipe the competition and not do very well. But the main thing is definitely like getting through scrutineering with the kind of electrical side of things. It's kind of an unknown to most mechanical engineers, and so there's a massive like kind of obviously health and safety kind of risk that is put on to the electrical teams. So I think scrutineering is like our kind of main kind of achievement to get through, and kind of the endurance event is kind of an afterthought because I think we've slightly realised technology's moved on a bit since we spec'd our battery, and I think we've worked out it's going to be tight getting to the end of endurance. That's assuming nothing goes wrong along the way. But yeah, there's an awful lot to be doing. Obviously, like you're saying, like kind of preparing to fail. So like having all your spare parts, like spare wishbones, all your nuts and bolts, like kind of worked out what you have on the car and then kind of making a spare list of all that. Yeah, literally everything, like nuts and bolts, brake pads, spare consumables like oil, kind of motor oil, coolant, and yeah, brake fluid and whatnot. So, but it's kind of from your perspective, because you guys have been to competition for like a few years.
Yeah.
Our team hasn't been to competition kind of ever. There's only 2 guys in our kind of team who went to a class 2 in 2018. So it's kind of what you don't know is like the scariest part, because you'll be working along throughout the year and somebody will tell you something or you'll learn something from like doing, and you're like, oh my god, I didn't know that until then. And it's like, how much more don't I know? So that's that's kind of the main kind of hard part.
Okay, so for you, the biggest challenge in some ways is the uncertainty.
Yeah.
I can understand that, and kind of getting back to the competition and all of the logistics that goes into it. It's interesting because from your perspective as a student who's about to graduate from an engineering degree, I guess this is in some ways a real contrast to the kind of academic side of student life, isn't it?
Yeah, definitely. It's something you're not kind of taught at university, either just by living or on your course. It's something, a kind of completely different skill you kind of need to work out how to kind of build upon. It's kind of just being very organised, but on steroids, and like working kind of everything out of the week. Well, yeah, kind of the week really, whilst you're at competition, and trying to think of every single scenario. And that's kind of hard to do when you've not been personally.
Yeah. So it turns out logistics is really hard though, right? I think most of the world's discovering that at the moment. And this is no different. Okay, let's move on and talk a little bit more about why it was that LJMU E-Racing has taken the decision to move from the internal combustion engine to an electric motor. So I to the extent that I did any prep for this, right, I had a little look on some of the kind of information sources available, and one of the things that kind of jumped out at me is that if you look at the GB new car registrations for Q3 of 2021, there was a 44% increase in the number of battery electric vehicles that were registered, and that compared to the same quarter in the previous year, you saw a fall of 41% in the number of petrol cars being registered and 66% in the number of diesel cars being registered. So it turns out this might have been the right decision. What do you think, Cameron?
Yeah, I mean, I'm an advocate for ICE in the terms of I'm a motorsport fan and I love it. However, I'm not a moron. I know kind of there needs to be a change from kind of conventional engines to either kind of, I suppose at the moment, hybrid, then EV or hydrogen. And it's definitely something as an engineer we're going to have to kind of learn to work with, because I think before with an ICE it was kind of, you wouldn't really think too much of electrical stuff. Well, I personally wouldn't. But with this, having the EV team, you're very aware of all the electrical systems, and maybe not so much how they work, but kind of have a general idea and kind of be very conscious of like the health and safety stuff.
Yeah.
And you know, it's more than just like don't put your finger in a socket. There's a whole lot of kind of things to be aware of. But yeah, and it's also important to, like, as an engineer kind of keep on top of the curve. So it was, you know, we could have stayed as an ICE team until like now-ish. At least we've got kind of the previous 5 years of experience of working with kind of electrical systems and kind of homologating a car into an EV car and not just an ICE.
Yeah. So from your perspective, Rhian, obviously you 2015 year when you led the team, started an internal combustion engine, but kind of looking back or looking forward now, what do you think about the decision to move to an electric car?
I think it makes sense. I remember when I was here at 2015, if you'd have suggested that to me, I'd have been like, whoa. I think, you know, if we stick with what we've got, we might actually complete the event this year. But at some point you do have to make that step, and as you mentioned, it's the way that the industry is going. It's the future for automotive, and like even myself now, I get in my diesel estate and think, should I really be driving this? Like starting to look into how can I afford an electric vehicle. So I think as an engineer, having that skill set, like you said, understanding the health and safety regulations around electrification and understanding all of the technologies and the interactions and stuff, it's something that isn't necessarily what a pure mechanical engineer knows, but it's the future, so we're going to need to know it. So I do agree with you, even now, like in my current role, I'm still learning so much about the electronics and all of the communications and stuff, so it would have been handy.
Yeah. And I think that's maybe one of the challenges that students like yourself, Cameron, and face nowadays graduating from engineering degrees, is we're going into a world where we expect increasingly high levels of integration between mechanical systems, electrical, electronic systems and computers. And I don't think a world where those kind of things aren't closely interlinked is really foreseeable now, is it? I mean, you're working for the small robotics company. I guess that kind of embodies that kind of fusion of technology, doesn't it?
Yeah, absolutely. Like our mechanical engineering team is really small compared to our sort of software and electronics team, because sort of 50% of the system is them. Sorry, it's probably 75% of the system is them, whereas we're only 25%. We're just what you see really, and the sort of the tangible sort of mechanical systems. But it's like, going forward, you think that it should sort of be multidisciplinary and everybody has an appreciation for each discipline.
Yeah. In terms of creating transferable skills for graduates, I think, from my perspective, as a subject head here at LJMU, it makes real sense for us to be focusing on the future technologies that you'll encounter more looking forward into your career. Cameron, you're still just on the cusp of graduating, aren't you? So, if we look at the trends, I think that having experience working with these kind of high voltage electrical systems is probably a good call. So I mean, just for the benefit of our listeners then, let's talk a little bit about efficiency. So in terms of the electric motor that you've got there, I know from the data sheets that we've got that we're looking at efficiencies in terms of being able to transfer the electrical power from the battery, which is its kind of fuel tank, isn't it, into mechanical energy. So it's somewhere around about 90%, is that true?
Yeah, as far as I'm aware. There will obviously be some, obviously it's no different to a combustion engine, you have the mechanical losses at some point, but you definitely, converting what would be petrol into power is definitely much more efficient, Yeah.
So I think the rule of thumb that we sometimes use is that, after the engine or after the motor in this case, we'd be looking at kind of best case scenario, maybe 75% efficient, so a sort of 90% efficiency multiplied by 70% efficiency. So we're probably somewhere in the region of 65 to 70%. Mm-hmm. So let's contrast it with an internal combustion engine. So for a petrol engine, I think it would be true to say that a typical figure would be somewhere between 35 and 37%. Is that right?
I was thinking mid-30s.
Mid-30s, yeah. Well, yeah, and so that means that for every sort of joule of energy in that fuel tank, we're only getting less than a third of that, or maybe around about a third of that back out, and then we multiply that by 3/4. So it's worse again. So there's a real efficiency thing here, isn't there? But what do you think the practical challenges of electric vehicles are still at the moment? What have you got any perspective on this, Rhian?
I would say safety, and I can't think of the word, but it's getting everyone on board. I think that's a concern. Like, I speak to sort of colleagues and friends about electric cars, and they all say, oh yeah, but the price of electricity is going up, so why would I get an electric car? And it's like, that's thinking very top level. You've got to think of the bigger picture. Your electricity could come from renewable sources. In the future, it could be cheaper, etc. Like, putting fuel into your combustion engine, you're always creating this debt where you're using something that's not sustainable. So I think that's that, getting people's mindset on board. And there's lots of sort of fear, I think, as well around electrification of vehicles. There's obviously the sort of like high voltages, but there's also some of the, I was at primary school this morning, and some of the kids were asking me about electric cars, and they were saying, but what if you can't hear them and they come around the corner and then they sort of run you down because you don't know they're there? And it's that sort of thing, and it's thinking about all of those ancillary safety systems that you need to make sure that they're as safe, or if not safer than what we have already.
Yeah.
What about you, Cameron? What do you think the biggest challenges are around electric cars coming up? Is it public perception? Is what the technical challenges?
Yeah, technical wise, I'd say probably kind of condensing the batteries, because at the moment they're pretty heavy, to say the least. I'm not sure how much a Tesla weighs with its batteries, but I think I'm right in saying it's not too light, or compared to a combustion engine at least. So yeah, and probably kind of talking about sustainability, like obviously when you kind of get petrol, or you have your petrol, it's gone through lots of processes and come from unsustainable sources. but the problem like EVs probably going to be facing is obviously you're mining a lot of like potentially lithium or nickel, and they are finite, so it's postponing the problem a little bit, but it's obviously better than I see at the moment. So I think that's a long-term problem that EV is going to face, and yeah, I think people are inherently kind of against change of any sort, sadly, but it's something that just kind of has to be forced upon people to an extent.
Well, we can take them along with it on the journey. I suppose that's sort of maybe part of what you'll be doing as the next generation of engineers, convincing people that these are. I mean, I think we could do a whole podcast just on this topic here, isn't it? Is lithium sustainable? Will we see wars in 20 years' time over the supply of lithium? I mean, a striking statistic is if you look at the energy density of lithium ion batteries, current state of the art, somewhere in the region of 0.4 megajoules per litre, whereas you contrast that with petrol, you're looking at more like 35 megajoules per litre. So the energy density is kind of 70 times higher for petrol, which is why you had a 5 litre fuel tank and you've got a 60 kilo battery. So these are the challenges that the next generation of engineers are going to have to sort out. Of course, the other problem with a battery is it doesn't get lighter as you run the electricity out. So that probably does at a quantum level, but not measurably. Okay, just thinking about time. Let's talk a little bit more about personal perspectives then. So, obviously, former student, it's something that you commit a lot of time and energy and passion to. So, from your perspective, Rhian, maybe a personal perspective on what you got out of forming a student,
Yeah. Well, I think the big thing is it does make you more employable. When you have that sort of thing on your CV, especially if you come across somebody that's also gone through it, then your interview just becomes a chat about forming a student. And even now, I think I've been out of university 5+ years, and I was talking about it this morning to school kids, and I'm currently going for my C-Eng, and it's included in my application there. So it's something that you just take right through your career, and as you mentioned earlier, it gives you all of those sort of additional skills and the skills that aren't just the sort of the maths, the materials, well, it does give you like project management skills, but it just gives you that extra bit that makes you a well-rounded engineer, I think.
And you, Cameron?
Yeah, I definitely say, as Rhian was saying, come interviews for a job is all I talk about in my interview for my job, and I could put it down to like probably 70% of the reason why I got this job was because of my experience in the team. You work with a load of people you wouldn't normally work with in a uni kind of course project, especially now with electrical engineers, it's something kind of your course can't teach you, how to kind of do all the other things as well as the engineering technicalities. Kind of, you're doing documentation work, which whilst it's kind of similar in that you get a grade at the end, it's much more open-ended to an extent. There's not a defined kind of description of what you have to do. It's very kind of open-ended, and just working kind of in a kind of larger team, in a structured team as well. It's something you really don't get at uni. Like once you graduate, kind of most people graduate with somewhere between a 2.2 and a first, but you've got to kind of separate yourself from them a bit. And it's a great way of showing you're like determined, diligent. You can work to kind of a common goal, and sometimes set those goals or lead people, or if nothing else, it's just a great way of kind of expanding your technical skill sets depending on what you want to do in the team. But yeah, it's something I only wish I got involved in earlier, really.
And I wish I'd stayed longer.
Yeah.
That's great. Really good account of that. You can hear some proper workshop noises in the background there. So we're just in a studio adding sound effects. So I think from my perspective, obviously I've been involved in the Formula Student team since 2010 now, I think. And I think all of the things that you you've just outlined kind of resonate with me in terms of having spoken to students who are involved and students who are kind of graduated and come back to visit occasionally, which is nice. And all of those transferable skills. So, you know, from our perspective, that's why we keep it as a kind of an extracurricular activity. And I think that has the benefit that it allows students who want to engage in it as something that they're able to do on an extracurricular basis can.
Yeah.
And add it to the CV as that kind of differentiator. So
yeah, I think Rhian was saying before, like, you put a lot of effort into it. And I know for a fact I probably put more, at least emotional effort into this than I did my degree. And it's something, because it's so like kind of personal to an extent that like you want to get to competition and see the car run and do well, you inherit a lot more of your time and effort into this, because I don't know, it's kind of hard to put into words, but like, yeah, you just care a lot for it, and it's something, not bashing university, but yeah, it's just,
it becomes your life.
Yeah, it feels like a real project, although it's kind of is, but it's not industry.
yeah.
But it feels like kind of university, but kind of real life.
Yeah, I think I can understand that. You know, you've got some personal investment in it, and it feels like you're doing it maybe kind of for your own reasons.
Yeah.
So no, I think that makes sense. Okay, so let's start to wrap things up then. So Cameron, you're leading the team to Silverstone July 6th through to 10th, I believe.
Yeah.
So people who want to come and support you can go to Silverstone, buy tickets online.
Yes.
See how far we get. What's next for you after that then?
So I got a job with a company called X-Track. They make transmissions for IndyCar, NASCAR, Le Mans. So I start that on the 18th of July. So yeah, pretty much come back on the 11th, tidy up here, graduation on the 14th, and then off to that.
Excellent. Well, congratulations on the job. X-Track's a famous company in that
area.
Yeah. And I'll be at Silverstone, but I'll also see you at graduation. So well done.
Thank you.
How about you, Rhian? You're at a small robot company at the moment.
Yeah. So hopefully that continues. You know, if anyone's listening, please invest. But yeah, I'm hoping that continues. I'm enjoying what I do, designing sort of agricultural robots. A lot different from what I was doing back at university and when I first graduated, but it's going well, and I hope it, keeps me going, keeps me in a job for a long time coming.
Excellent. Listen, Cameron, Rhian, thank you very much for your time. It's been great to speak to you both, and maybe we'll do it again sometime.
Thanks for having us.
Yeah, thank you, Christian.